Hey everybody, MS Farzan here, and welcome to part 2 of this video series. I hesitate to call it a series as it's really just been a couplet so far, regarding making a multiplayer 2D card game using Defold. I published a video, just a basic video on the single player aspects of making a 2D card game in Defold, and using the one of the libraries put out by one of the developers on Defold, Björn Ritzl, and which is called the Defold Input Library. And I don't know, I just kind of got interested in about how would you reproduce the functionality of a multiplayer card game, similar to what I've done in JavaScript using Phaser and Express and Socket.io, and as well as my other videos in Unity using Mirror, and of course C# to handle the multiplayer aspect. So I did some digging and created a very basic example of how this could work, and I thought it'd be interesting to just share this with you in case you're working on something similar or looking for something like this. This isn't going to be a step-by-step tutorial. It's just going to be an overview of this template that I've created, and I'll walk through some of the code and how it works. All of the code is available in the GitHub repository for this video, which I've shared in the description for this video. And of course, you can feel free to join our Discord and ask any questions. I've also found the Defold developers and community to be super helpful, whether on the forums or on Discord, elsewhere. So if you have any questions about that side of things, I'm sure they'll be willing to help you, and I sure will be able to help you as much as I know about Defold. One of the main issues that we might deal with in this kind of game is how to handle the backend, and there are many different solutions, third-party solutions for this. For example, Colyseus and Nakama are two. They seem to be like the two biggest supporters in terms of what you can do on if you need multiplayer services for Defold. And I after doing some digging, I just decided to work with Colyseus, and I'll explain why in a moment. But let's just see how the game, if you can call it that, works. What I have here is I've built on the right hand side of the screen. I've built the game using Defold's just build function, Control B, and I've also built it in an HTML version, also through the Defold editor, just so I can have two screens open. It's the easiest way that I've found to do it. And what's going to happen is each of these clients is going to communicate with a server that I also have running, a node server that is running Colyseus, and communicating messages between them. So when I click this draw cards text, which is to serve as a button, not only should I see cards displayed on the client that called that draw cards method or function, I should see the backs of those cards on this other client, the HTML client, and vice versa. So I'm going to do that. You see that I've drawn 5 cards here, and then on the client that called it has 5 cards face up, and the client that did not call it has received a message from the server to deal 5 cards face down. There's some functionality associated with the cards too, whereas like right now, of course I have this like on a teeny tiny window, so you can't see pretty much anything, but if the window were bigger, of course the cards would be a little bit bigger. But I've added a feature here where if you mouse over the cards, they should have a replica version of that card that's a little bit bigger, so it's easier for you to see the text on screen. But while I can do that with my own cards, I cannot do it with these face down cards. These are just kind of like duplicates that are meant to just hang out there. Now, when I draw cards on the HTML version, Defold helpfully just replicates that. So now I have like the image of like a playable game. There's not really much game to this, but something that I've added as well is when I drag a card, and similar to the previous video, I've created a basic drop zone here. When I drag this card and I drop it in the drop zone, what the server does is it sends a message to the other client, the non-dragging client. It deletes one of these duplicate cards up here, and it renders an opponent version. I'm saying that in this case the owning client version or the player version are these cyan or blue colored cards, and the opponent renders the same card in the drop zone and of this magenta color to let you know that that wasn't the card that you played. Somebody else played that card. Similarly, if I drag and drop here, an opponent card is displayed or rendered in the original client, and we can just keep going back and forth and back and forth. And this renders sequentially from left to right on both clients until all cards are done. Very basic setup, but what's important here is that the architecture behind all of that can be used for pretty much, well, I shouldn't say any kind of card game, but the basic structure is there. And at the same time, we're logging messages to the console so we know when game messages are being passed between clients through the server, or when we're dragging cards, and so on and so forth. So all of that works great. I'm just going to close these windows and we can take a look at the actual code. What do I want to say about this before we get started? The front end part of it is not all that different from what we dealt with in the first video. There are some additions to enhance the communications and some other things that that I've just kind of updated. The backend stuff is written in JavaScript in Node.js, which if you're only been coding in Lua, it might be a little bit of a learning curve, but I'll try to walk you through some of the key points. And I'll also link the documentation for default input and for Colyseus, both the client side and the server side, in the description of this video. I've also helpfully separated all of the different game objects and scripts into a more clearly denoted file system here, and commented on pretty much all of the scripts, so you'll have some indication of why things are working the way that they are. Let's start with this game.project and see that in the project window we've added two dependencies here from the previous time. Not only do we have default input, but we also have to add this Colyseus default library, which is for the client side of the game. And we also have, for that to work, we need to use the default extension, which allows us to work with WebSockets. So if you're not familiar with networking, you're going to have to get really familiar with it, as I have had to for making multiplayer games. Essentially, what we're working with here is the separation of what's called a client and a server. If you've only done single-player games or followed the first tutorial video in this couplet or series, then you probably only worked with the default engine, and that's all you ever needed. When you go to project, build, it builds a version of the game that can be considered a client. That client is so far just like a single-player game that you might run on your desktop or on web or mobile or wherever. But to communicate with another client, and that is like in a different country or even in another computer on your network, if you're not doing what's called peer-to-peer networking, where they communicate directly with one another, you're going to have a server that exists elsewhere that manages the communications for you. So the server sits somewhere, probably like in an Amazon, server farm or whatever, and it is just waiting to receive a message that a client has connected to that server, and then it handles the communications between different clients. And from one client to the server, back up the chain to another client, and vice versa. And so Colyseus is a multiplayer server solution that helps you to do that. And it also works for JavaScript game engines. It also works for, I think they have a Hacks version and a Unity version. So like it does a bunch of stuff on the front end where you can use different clients from different game engines. But on the back end, it's basically working on a node server that takes that works on JavaScript or TypeScript. We also talked about in the previous time that if you're having issues with display, you might have to update your your graphics. You might have to update your texture profiles. Okay, so once you install those or you add those to your game.project project settings, you'll have to go to project and fetch libraries to make sure that you download them. And then I guess let's go from top to bottom and just kind of check out what this template does for us. Under the assets directory, I've included a version of the cards, both the backs and fronts, just of like one card from one of my games, which is called Entromancy Hacker Battles. And also this blue button from the Defold input library that we basically stretch to fit our, let me bring it up, fit our drop zone. So all of your assets could live in this directory. In the atlases directory, you'll remember from the previous video that we need, whenever we want to reference sprites, we need to store them in an atlas. So we've got an opponent card atlas, a player card atlas, and then the UI atlas is where that button lives. We have a series of game objects that these are kind of like blueprints that we want to be able to instance or create at runtime. I've got an opponent card, opponent card back, and a player card. Each of these game objects has a base level game object, and then it has a script attached to it. It's the card script. And then it has a collision object with a box, which is basically the same size as the game object itself. And the sprite attached. The only difference is that the opponent card back doesn't have a collider attached to it because it does not need to be able to detect collisions from the cursor or for any other reason, because they're just duplicate cards that need to sit there and be deleted as we so please. Now, if you have any questions about this, please just review the initial video, which deals with the cursor and dragging and dropping. There's a GUI folder that stores our text here, which has a text Gui script attached to it. We haven't done anything with the game input binding. We just want to make sure that when that this input button 1 from the mouse, the action is touch, which just means that you're when we click the mouse button, we want this action to be produced, this message to be sent. Okay. Let's look at our main folder. This is where the main collection lives, and the main collection is the default collection that is loaded when the game starts. You can change this as you like, but in this case, it houses a client, which is just a game object that I've included in here so that it can run this client.script, which we'll take a look at in a moment. It houses a cursor, which was covered in the previous tutorial, but I will talk a little bit about what the cursor scripts do, the cursor controller script does, because I've changed that. It houses the drop zone, which has its own collision object. It houses a game manager, which is going to store information about the state of the game, like if somebody's played a card or if we're doing we need to keep track of numerical values or health or whatever. It's got the GUI game object, which is just a place for us to store our text GUI. It also has a spawner, which has 3 different factories that, as you might recall in Defold when you want to instance a card or create a card or a game object at runtime, you need to have a factory that will then produce that game object from a prototype. And we've based that on the opponent card back game object, opponent card game object, and the player card game object. So one thing before we get into the actual scripts is to notice that in these game objects, and we mentioned this previously, the collider for the drop zone, for example, is of the group drop zone, and it collides with a mask, which is the cursor, player card, and opponent card. On the other side of things, the cursor has a collider that is of group cursor, and it collides with player card, opponent card, and drop zone. So that means that when you want something to collide with another thing, like we want our cursor to collide with cards so that we're able to determine whether or not the cursor is above a card, you're going to create a group for that game object, and the mask is whatever it's going to collide with. So if we went into our opponent card game object, for example, the collision object or the collider is of group opponent card, and it collides with the cursor. That's important because we want to make sure that when as we'll see, as the cursor mouses over one of these cards, if it collides properly, then not only should we be able to drag it, but we can also render that larger version of the card that we saw during the live demo. Okay, so there's a few scripts here, and I just accidentally moved the game objects into the wrong folders. I don't know how that happened. Okay. And what I love about Defold, by the way, is that like you just move stuff around. It doesn't like even matter in terms of your file system. You don't have to change your folder what is it, the URLs or anything like that. Because when these things are rendered are created at runtime, they all have these URLs, which is just hash collision object or this card.script. Where am I looking here? This client, for example, just has a URL client, or the game object here. Card.script, the card script just has the URL hash card. So like if you created a bunch of different folders and you're just like, I don't want this here, you can just move it around. It's awesome. Okay, so the easiest one to look at first is the card.script, which we already looked at in the previous episode. And we're using go.property to demonstrate that if you want to access, if you want to expose certain variables so that other scripts can access them at runtime, you can just say go.property and then set your variable. So we're saying when a card is instantiated or created, its isDraggable property, which is something that we created, a Boolean that we created, should be set to false. And this changes based on the circumstance situation, as we'll see. Let's skip over the client for just a second because there's a lot of stuff here, and look at the cursor controller. I've changed some of the things here, and I've commented a whole heck of a lot of things here. So the important thing is that the important things to note before you dig in on your own is that we import the cursor script from the in folder, which is default input. We start off by saying that the cursor shouldn't be able to drag cards unless we tell them to. We store a variable, which is the URL for our game manager, which we'll look at in a moment. We also start saying that we're not zooming in on anything, and we save just an empty variable called a zoom card. I'm not going to go over the dragging stuff since we talked about that in the previous session. But I will say that in this this whole function body of onMessage, this is when we receive information from input that we're forwarding all of the input that we're receiving from the game, or we're forwarding actually to this message system so that we can handle what happens here. So for example, if we receive a cursor over message, drawing upon not only default's input system, but also the default-input extension, you can uncomment a bunch of these comments if you want to log information about the message and the X and Y values of the coordinates of the message, etc. We want to track when the cursor is over the drop zone, and essentially if we do, then we're going to also determine logic for what should happen if we're able to drop the card into the drop zone or not. But then there's also this section that we're saying that if we're not already zooming over a card, then what we're going to do, we're going to use the player card factory to spawn a larger card, which is this tiny thing right here. We're spawning it at 0.66 scale rather than at default we're doing 0.33 scale because these cards are actually pretty huge, the sprites. And we want to determine if it's an opponent card or a player card based on their groups, and then we'll spawn that version. When the cursor's out, we want to say if it's going out over the drop zone, then we want to say that this local variable that only exists within this script is false, and we want to delete the zoomed card so it just doesn't just hang out there. If the card's being pressed, if the game object's being pressed and it's a card, we dealt with this in the previous session. We want to determine whether or not we can drag that card, and then if it's released, we say okay, then no dragging. We're not doing anything if the cursor is clicked. We are doing a little bit of magic here. I shouldn't say magic. We're adding a bunch of logic here to make sure that the Z position of the game, of the card that's being drawn, is incremented every time a drag event happens. Because you might notice in the previous video there were some issues where you try to drag a card and it would just sometimes it wouldn't come to the top, so you'd be dragging it under other cards or other game objects. So what this does, it accesses a variable that's set in the game manager, the Z position, which is kind of like globally defined here in our game template, and it just increments that. So we're just keeping we're just like incrementally incrementing the Z position of whatever is being dragged so that it always stays at the top of the screen. And then we have a lot of cleanup at the end of the drag event. So like we want to not only update the Z position, but we also want to make sure that we can't drag cards after they've been dragged and dropped in the game in the drop zone. And we also want to increment this, we haven't looked at this yet, but this other property in the game manager, which is called cards played, so that we can keep track of how many cards in the drop zone and increment that accordingly, so the cards are placed from left to right and not on top of one another. And then we also have this tiny little message post to the client, which exists here in the main collection. This little word drop. So we're going to look at why we do that and how that works in just a moment. So just leave the networking for just a moment. This is part of the networking procedure. The game manager, right now it just exposes 3 different properties. This Z position we talked about, the number of cards played, and the cards in the opponent hand. I'm going to caveat saying this is not the most elegant way of doing what I'm about to show you, but and I'll express what probably is the elegant, better way, but whatever. Finally, there's the text Gui script, which we looked at before. All we've done here is we've offloaded the before we treated this as a button, and when we click the button, we created 5 player cards and 5 opponent cards. All we've done here is deleted the opponent cards factory bit, and we've offloaded that onto the client to say we need to send a message to the server that we've drawn cards, and then have the other client handle what to do. Okay, so let's look at the client first, and then we'll look at the server. So when you get into the nuts and bolts of this, it's actually fairly straightforward. It's only that if it's your first time doing any networking, it can feel like a lot to handle all at once. So the first thing we do is we import the client script, essentially that Colyseus has prepared for us. We create a local client, local to this this game object, local room, and also we're saying create a what's called a table in Lua of called opponent cards, and we want to reference the game manager, so we just save this URL in a variable, so I don't have to keep writing it over and over again. So on when this game object or script initializes, we want to set the client to a new client, and it's going to be listening at our local host port 2567. When you deploy your game, obviously you'll have to do some deployment configuration both on the server side and the client side, so that the clients and servers are listening at the same on the same port of the process of whatever's happening, not on your local server. So that will take some work. Sorry, not on your local machine. That'll take some work. We're going to create a game room just called game, and if there's an error, print the error. Otherwise, print to the console successful. And we'll set our local variable of room to this the room that is passed to us, or that we're passing to it. Okay, and now this is the way that the Colyseus client handles messages. That we say room on message, and then we have the type of message, and then we run a function based on that message. And here we're just printing to the console what the server message is. And we've separated out when we receive a game message type. With that message, we're going to print what the message is. And if the message is draw, meaning somebody has clicked the draw button that is handled by the text GUI script, what we should do is use our opponent card factory to create 5 opponent cards, opponent card backs. And I'm going to explain what we do in just a moment here. Otherwise, if the message is to drop, like we saw in the cursor controller script, then we should handle what should happen by dropping a card in the drop zone, and or creating a card in the drop zone as though it has been dropped, an opponent version of that card, and then we should also increment the cards in the drop zone in the game manager, so that we can continue to increment from left to right, irrespective of who's dropping those cards. Now, we do a little bit of work here to keep track of. So in the game manager, I need to have a way of determining how many cards are in the opponent's hand, so that I can delete which cards in the opponent hand, so I can delete them sequentially when they're being dropped in the drop zone. Now, one of the ways that I would like to do this is to expose a variable here, cards in opponent hand, which is actually a table that or like an array that allows me to keep store all of those cards and delete them as I see fit. Unfortunately, it seems as though, or I'm sure there's a reason for this, it seems as though the types of variables that you can set as properties in Defold are limited to things like numbers and booleans, nothing as complex as a game object, or I'm not even sure that you can set, I think you could probably do a string. Actually, I'm not even sure. Don't take my word on that. But you can't have one of the properties be a table or an array. So what I've done is I've just created an integer here that can be incremented by the client, and I'm storing the actual names of the opponent cards, or at least of their instances, in this local variable opponent cards. And then when a game object or a card is being dropped in the drop zone, what we're doing is we're seeing how many cards are in the opponent hand. We're deleting one of them from the cards in the opponent hand, and we're likewise deleting one of the opponent cards in our local script here. And then we're setting the game manager cards in opponent hand to the number of cards that exist in this array that we have local to this script. It's just like a little backwards, and I realize that, and I'll explain a better way of doing it. But essentially the loop is we start out with 0 cards in the opponent hand, and that's represented by this number as a property in the game manager. And in the client, we have an empty table here. As we draw cards, we store their URLs or their names, which is like instant 1, instance 2, instance 3, in this table as an array. And then at the same time, we increment this number in the game manager. As we drag and drop cards, they will not only will we decrement them here in the game manager, but we'll also delete them from this table here, and that's how we keep track of it. That's just not a great way of doing it. And I think what I would do instead is, rather than try and shoehorn this into a property, what I would do here is just create a local variable here, which is the where do I have it here? This local opponent cards variable. I would just store it in your game manager, and then have a whole series of messages being passed. So you could say something like, where do we have messages here? Function on message, which is part of like every template script. Send a message from whenever you need something to happen to that variable, you just send a message from this script to your game manager script and tell it to update that table. That's probably the more elegant way of doing it, but whatever. Your mileage may vary. You can determine what to do. And then now, just at the bottom of this script in the client, we're receiving messages from the cursor controller that when we click the draw cards text, it's going to send a message to the server of the type game message that cards have been drawn, or if we drop a card, it should send a message to the server that the card has been dropped. Okay, hope that's all clear. It's also all commented. And the outstanding place to look now is the server. Now, the server has a whole heck of a lot of stuff. And what I recommend to do is to take a look at the documentation for Colyseus, both of the client side and also the server side. Because the server side, I just went through the basic installation process on Colyseus and then started to edit as necessary. So you'll have to install Node.js if you don't have it, and I think you're most likely want to use a different IDE or editor to handle that side of it if you're not already doing that for your Lua scripts. I use Visual Studio Community Edition, and that works fine for me. So I wouldn't do all this editing here because I need a little bit more overhead in terms of my tool set or tool chain. But the important bits are, if I'm in the server folder, you'll go into the source folder, and the index.js is the entry point for your script. You really don't have to do anything here. I certainly haven't. What you will see is that if you install directly from the Colyseus instructions for how to install it using the Node package manager, npm, there will be some things that I've changed here. For example, like just the name of the room that we're calling is not, I think it's installed with a chat room or something. I just changed the name to game.js and changed some of the values here to make sure that it works appropriately. And the main body of interest here is this game.js folder. And I'd like to take a little bit of time to walk through this. First, saying that if you're doing anything complex with the state of your game, you'll probably want to use this schema functionality, I should say, that is being offered by Colyseus. I'm not using it all here. I am importing this game state schema that they've created for us, but I think I named it game state instead of chat state or whatever it is. But I'm not using it for any reason. I'm leaving it here so that you have it in the architecture if it is useful for you. What I will say is that I have done some work here to provide some of the structure for what the communications between your clients and the game server could look like, and this is what makes the magic happens in our game here. I haven't used the schema at all, but you probably would want to do that if you have like a very complex game state with like cards all willy-nilly here and there, and keeping track of player decks so that you can reference them and make, on the server side, to make sure that people aren't cheating by moving things around on the client that they shouldn't be able to. But here, this is a 2-player game, so I've supported only 2 clients being connected. When the room's created, it's going to log to the server console rather than the, which actually I still have running here. It should log to the server console any options that are being used, and you might remember that we create the game by via the client, or join it if a game room has already been created. And there are no options here, which is why we just see these empty squiggly lines. And then we're going to set the game state, which we, like I said, haven't used. Now we work with message passing. When the message is received of a type message, just broadcast it with a type server message to all clients. So when it receives a message of the type message, we want to log to our console that a game room received message from the client ID and whatever the message is. And we're going to broadcast, which means send to all clients, a type of message called server message. And we'll just say whatever the client is and then the message. So we see this on a couple of different examples, and I'll walk through this in just a moment. When we receive the type game message, which we also defined in our client on the client side, broadcast it to all clients with the game message, with the type game message, except for the client that sent it. So this is how we work out the logic of, I just drew cards and I want to send a message, but I don't want to receive a message that says, hey, draw cards, and then like I have duplicates of cards on my screen. I just want clients that haven't already drawn cards to see that another client has drawn cards, and then handle that accordingly. And that's how we do it, by saying except client. When a client joins, log to our server console that the client ID joined and broadcast to other clients a server message that the client joined, and same when the client leaves, and also what happens when the room is closed. So we see on the server side all this stuff that just happened. We're listening on the same port that the clients are listening on. When a client joined, it created a room called the game room, and then we see this unique ID of one client joined and a different client joined, and we also see when they left, and then we also see when the last client left, it disposed of that room. At the same time, on the client side, and we don't have the HTML version open for us to really see this, on that side of things, we do see that it's receiving client messages where the WebSocket connected, it was successful in joining the room. We received from the server that this other client joined. We have some local information being passed that we're pressing a button. We drew cards. Then we received a game message to draw. And we received a game message that the card dropped, and so on and so forth. And then we know when the client left. And then we closed the session. And that's basically the long and the short of how this seemingly complex, but actually very simple in terms of multiplayer card game template works. I highly recommend just clone the Git repository, poke around with it, look around the default input examples and documentation, look around the Colyseus documentation, and start making this your own. Like I said, I didn't use a schema here. You certainly could. I'm just handling this with message passing, partially because that's what I've done on the JavaScript side of things with Socket.io, and not too dissimilar to what I've done in using Mirror in Unity. But the great thing about this is that you can use this as you see fit, and hopefully learn from the comments that I've left in the scripts. One thing that I would say is that clearly if you're using Defold, you're locked into using Defold for the client side of things. But if you don't want to use Colyseus, you could use something else for the backend. You'd have to change some of the front-end client functionality, obviously, to work with, let's say, Nakama or some other framework on the backend. But you're not locked into using Colyseus. I do think that Colyseus offers certain multiplayer functionality like matchmaking and server load balancing and, I don't know, a bunch of other doohickeys and doodads. So it's certainly worth using instead of I guess like just a base WebSocket implementation or Lua socket implementation. That's one of the reasons why I think people look to things like Colyseus. And I guess there's like a domain knowledge expertise which goes along with it, where if you have some skills in JavaScript and Node, you can certainly apply them to Colyseus. And if you figure out the Colyseus backend and then wind up using Unity or using Phaser or using something else for your front end, well, you already have that built in terms of the back end, and you just need to scope out what the front end, the client side, looks like. So yeah. Anyway, I hope this has been helpful for you. Please do dig through this project and let me know if you have any questions. If it would be interest to you to have more tutorials like this or step-by-step for Defold or Colyseus or what have you, please feel free to let me know either here in the comments for this video or on Discord. If the video has been helpful for you, please do be sure to like it and subscribe for more. I'd love for you to check out my books and games at nightpathpub.com. You can also join our Discord and follow me on Twitter for more, and we'll see you soon.